Hello everyone, welcome to Artisticatom channel. I'm Fatima and this is part 2 of Check Your Progress question answer discussion. So let's get started. So in the previous session, we have completed questions till 2.5. In this session, we will solve all the questions left from 2.6 onwards. So the question 1 is, Zara heated a liquid and recorded its temperature every time. Here are her results. So this question is experiment based. You can expect such kind of questions in your exam. So here is the whole experimental data that she has collected given in your book. You have to make sure to follow these values only while plotting the graph and solving the different questions asked based on this. So the question A is, copy the axis and label below onto a graph paper. So here is the graph paper guidelines, or the way it should be plotted on the graph is given, and you have to make these proper axes on the graph paper given to you by your teacher. So now when we are plotting a graph, we have to make sure to follow these guidelines. Firstly, we will make sure to use a sharp pencil. Now, if your pencil is not sharp, you will see inappropriate or improper lines on the graph paper, which will make it look shabby, and hence you will lose marks over there. Nextly, you will make sure to use a ruler. Thirdly, you will make sure to use appropriate scale for the size of the graph paper. Now, suppose if we if we take the example of this particular data given, so we can see that the axis values given, or the scale given, is as follows: 0, 1, 2, 3, 4, 5, 6, 7, 8. So here they have taken a difference of 1 unit, and we can see that it is clearly covering the whole graph paper. But suppose instead of using this 1 unit difference, if you use 2 unit difference, then what will happen? This part of the graph paper will remain unused, and it will not be considered as an appropriate or ideal graph, because you have to make sure to cover the graph paper. So hence, according to the size of your graph paper, you have to select the scale or decide the scale. Now nextly, make sure to label the axis. Now sometimes students, what do? They mark these values on the axis, but they forget to label the axis, and which makes it little difficult for the examiner to determine what exactly these values are representing on the graph paper. So make sure to label the axis on the graph paper. Nextly, make sure to plot the accurate points. Suppose if the point value is given at is at 30, so you have to make sure to plot it at 30. If you are plotting it at somewhere, some or the other place, like 1 unit below 30, then it will not be considered. You will lose marks over there. So now, following these guidelines, I have plotted this graph. So as you can see over here, this is the graph given, and when I have plotted these points, you can see at 0 minutes the value of the temperature was 20 degrees Celsius when Zara has recorded it. So at 0 it is what, 20 degrees Celsius. So as you can see how accurately I have plotted, in the same way you have to plot it on the graph paper. Now, once we are done with plotting the graph paper, now let's move ahead and solve the next question. So the next question is, draw a line of the best fit through the points you have plotted. Now, when we have plotted this graph, we can see that it is not a straight line, okay? Or so since it is not a straight line, we are not going to use a ruler or draw a line. Since it is a curve, the trend of these point is in the form of a curve. We are going to draw it freehand, okay? So if suppose if it is not a curve, then you have to make sure to use a ruler to draw a straight line. Now, as you can see here, I have left this point, the value at 2 minutes. Now, why I have left it? Because here in the question, it is asked to draw a best fit. So best fit means you have to draw, suppose if it is a curve, then you have to draw a smooth curve. Even if one or the two values, whatever is not fitting into the curve, you can leave them, you can ignore them, and you can plot a smooth curve whenever it is asked to draw a best fit. Now, secondly, if it is a straight line, you have to make sure to draw a best fit straight line. Now, what do you mean by best fit straight line? Here you will make sure to draw a straight line in a way that the points which you are leaving are balanced on both the side of the line. Like for example, if I am going to draw a straight line through this, I will make sure to draw it in a way that the points on the right hand side of the line and the other side of the line are exactly equal number, so that the line which I am drawing is the best fit for that particular graph. If you haven't understood this concept, then I will also make another video based on how to draw a proper graph. Now for this question, since it is not a straight line, which I'm not going to go in deeper, and I'm just going to ask you to draw a smooth curve following the trend of these points that you have plotted, and make sure to ignore this point because it is not fitting the pattern. Now the next question is, which reading does not fit the pattern? As we have discussed just now, that this particular reading is not fitting the pattern. That's why we have ignored it and we have drawn this particular curve. Now, how you are going to answer this question? You will write the exact value at which it is not getting into this pattern. So you will write answer like this, that the reading of 19 degrees Celsius, if you extrapolate it on the y-axis, you will see that it is going to coincide at the point of 19 degrees. So you can see that 19 degrees at 2 minutes is the value which is not fitting the pattern. Now the next question is, suggest a reason for this. Now when this error may happen, so suppose whenever we are doing experiment with a thermometer or any other instrument, there are possibilities of human error. Now what do you mean by this human error? Sometimes when we are using or handling that instrument, we might not use it properly or handle it properly, due to which there might be error in taking the reading. Like for example, here in this case we are using a thermometer. So when Zara is using a thermometer, she might have not folded it properly at her eye level, as I have explained in my previous video when I was explaining that topic, how to use a thermometer. So she might have not handled it carefully or not holded it properly at her eye level, due to which she has misread the thermometer, and hence this might be the reason for the incorrect value that she has got. Now the next question is, what happens to the temperature between 5 and 8 minutes? So if we go to this values, that is 5 minutes and 8 minutes, we can clearly see that the temperature is not increasing as it was increasing earlier. So this means the value is almost same. Okay, it is almost or fairly same. So we can see that the values are almost constant. Now when this happens, that the temperature of the system remains constant, well, as we have discussed in our previous sessions also, where I have taught you the concepts, you will remember that I have mentioned whenever there is change of state taking place during that time, when the system, that until the temperature or the whole system gets converted into other state, the temperature of the system remains constant. So whenever there is change of state is happening, until the whole system converts its state from that particular existing state to the new state, the temperature of the system remains constant. So here we have started heating this liquid. So as we can see that as the temperature of the liquid has started increasing, at this particular temperature it has almost become constant. So as it has become constant, we can clearly see that the state of that particular system has started changing. So this means the liquid has started boiling. So we can write the answer for this particular question as what? The temperature remains fairly or almost constant. Now what could be the reason? As I told you, since here boiling is happening, which is nothing but the change of liquid state to gas state. So until and unless the whole liquid gets converted into gaseous state, the temperature of the system remains constant. This is what we have learned in our sessions. Now the next question is, the diagram in the boxes shows different arrangement of particles where each color represent a different atom. So here we are provided with the representation of different particles or the atoms in different system. Now what we have to do with this? So the question is, give the letter of the diagram that represents a particle of a compound, particles of an element, atoms of a mixture, atoms of an element. So when we talk about particles of a compound, so what do you mean by this term compound? So whenever we have different atoms present in a system and those atoms, they are chemically bonded, we call that particular substance as what? Compound. So we can see that among all these four images, only in case of B and D, we have different atoms present in the system. But in case of B, we can see that there is no chemical bonding. They're just present. There is no bonding. And in case of D, we can see that there are different atoms and they are chemically bonded together. This means this particular image represents compounds, particles of a compound. Now the next is particles of an element. So when we talk about particles, particles is a broad term which includes atoms, molecules, ions, etc. So when we talk about particles of an element, it may include individual element or individual atoms, or it may include same kind of atoms bonded together. So as you can see in A and C only, we have same kind of atoms present in the system, and in A we have just single atoms, and in C what we have, the same kind of atoms bonded together. So we can say that A and C are the particles of an element. Now the next question is atoms of a mixture. So when we talk about a mixture, so in that case what happens? We have one or more substances present, but there is no chemical bonding. So in that case we call them as what? A mixture. So here, as we can see here, we have different atoms present, and at the same time there is no chemical bonding. This means they're just mixed together. So we call it as what? Mixture. So B is the answer for this particular question. Now the next is atoms of an element. So here they are specifying atoms. So here you cannot take this molecule where the same types of atoms are bonded together. This is incorrect because they're talking about what? Atoms. So we will select A as a correct option. A as a correct option for this particular answer. So here is the answer. You can refer to this, even you can revisit this video where I have explained the whole concept in detail. Now the next question is 2.8a. Give the symbols for each element. So here we have the name of the elements given. We have to write their symbol. Now for magnesium, the symbol is Mg, as you can see over here. Now for oxygen, the symbol that we use is capital O. For hydrogen, we use the symbol as what? Capital H. For calcium, we use the symbol as what? Capital C, and small a is the symbol for calcium. And for boron, it's capital B. Now the next question is name the elements with the given symbol. So here we are provided with what? Symbols of those elements, and we have to write their name. So C stands for what? Carbon. Na represents what? Sodium. K represents what? Potassium. Cl represents chlorine, and Si represents what? Silicon. The next question is explain why scientists use symbols for the elements. Now, when we talk about the symbols, so here we can see that when we are writing the name of this element in a periodic table, suppose, consider or imagine that if in the periodic table, instead of the symbols, the whole name of the element was written, then it becomes very difficult to adjust their full names into that small space. At the same time, it takes a lot of time to make it, and at the same time it becomes difficult for the reader to understand what exact element was given over there. So hence, in order to overcome these issues, that is to save time and at the same time to save space and fit all 118 elements into that small periodic table which can fit on a single paper, it becomes easy to use their symbols. So that's why we use symbols for the elements instead of writing their full name. Now the next question is explain why some symbols such as chlorine, silicon have two letters. Now as you can see over here in this image, there are more than one atoms which have where their name starts with C. So it becomes, suppose if I give C as a symbol for all three or all four elements, then what will happen? It becomes difficult for the users to understand whether this letter is representing carbon, whether this letter is representing chlorine or calcium or copper. So hence, in order to avoid that confusion, scientists have come up with this idea that instead of using a single letter for all the elements, what we can do, for other elements we can use the second letter of their name, which makes them distinguishable and easy for the users to understand for which name these letters stands for. So this is why we use two letters for some of the elements. So with this, we have completed our session. Thank you so much for watching. Do like, share and subscribe to my channel. I am going to upload all the workbook answers too. So stay tuned with me